we will now in this particular lecture cover two important protocols, Z-Wave and ISA 100.11a. These are two very important protocols that in addition to ZigBee, HART, wireless HART, Bluetooth, RFID, NFC are also used for building IoT systems. However, whereas ZigBee is more popular for all sorts of IoT systems, used in IoT systems, Z-Wave is particularly attractive for building home automation systems. And as you know by now in this course that home automation is one of the important application areas of IoT. Home automation includes what? Home automation includes things such as having some kind of a robot or having mobile phones that will do number of different things. Different day-to-day functions at homes can be done spontaneously and so on and so forth. So, how can it be done? This is what home automation does. So, automating different functions at home is something that is of primary concern of home automation. So, I was talking about Z-Wave. Z-Wave is a technology which comes from the Z-Wave Alliance. So, this Z-Wave Alliance, in the same way as we have a ZigBee Alliance, we also have a Z-Wave Alliance, and this Z-Wave Alliance is particularly pushing for making this technology very attractive to support different home automation applications, different home automation functions. And we are going to look at how using Z-Wave we could be able to improve the automation of different functions using different IoT devices at home. So, we look at this Z-Wave. Z-Wave is also written in different ways. We could be writing Z-Wave altogether, or using a space in between Z and Wave, or using a hyphen in between Z and Wave. And this is a protocol that is used for communication between different IoT devices for home automation, as I just said before. It uses RFs for signaling and control, and the operating frequency for it is different from the ones that we have seen. We have seen that primarily the other things like HART or NFC etc., they all operate in the 2.4 gigahertz band, and for Z-Wave the operating frequency is 908.42 megahertz in US, 868.42 megahertz in Europe, and for different other countries I will show you in a short while that for different other countries there are different other frequencies of operation. So, in Z-Wave there is some kind of a mesh network topology that is formed and maintained between different nodes, which can be up to about 232 in number in a single network. Now, let us look at some interesting points in Z-Wave. So, we have, let us say we are talking about home automation. In a particular home there could be different rooms. Let us say this is room 1, room 2, room 3 and room 4. In Z-Wave, if we are using Z-Wave, there is something called the Z-Wave controller, and there are different Z-Wave devices that are there. So, typically in a single home there is only one Z-Wave controller, and there could be different. So, These are all Z-wave devices. One Z-wave controller and one or more, that means several Z-wave devices. These Z-wave devices, they could be either connecting directly or they could be connecting with the help of a relay node in between. So, this is one Z-wave device, this is another Z-wave device, and this could be a third Z-wave device. And this could be something like an ad hoc mode of communication. Okay. So, this is how Z-wave basically functions. So, I was telling you that in US 908.4 and 916 frequency bands, in Europe 868.42 and 869.85 megahertz frequency band, and for other countries these different frequencies of operation are shown over here in this particular table. So, as we can see that for India it is 865.2 megahertz operating frequency. A very interesting and important concept is Z-wave does not use FSK modulation directly. What it does is it passes through a Gaussian filter. So, essentially what happens is it becomes Gaussian FSK modulation, and the channel encoding scheme that is used is Manchester encoding. This is one concept. The second thing is, as I was mentioning earlier, there is an entity, a single entity called the network controller, the central network controller, that sets up and manages a Z-wave network. Each logical Z-wave network has one home ID and multiple node IDs for the devices in it, and that home ID basically corresponds to a single network ID. So, essentially, because there is only home ID which is unique to a particular home, the other networks in other homes will not be able to communicate through between these different homes. I hope that my point is clear. So, what I am saying is that every home has its unique home ID or network ID, and in that particular home only that other Z-wave devices will be able to communicate. So, they will not be able to communicate with other homes. The Z-wave devices in a particular home will not be able to communicate with other homes. So, we are restricting this communication of Z-wave devices to specific homes. So, nodes with different home IDs cannot communicate with each other, and we also have to keep in mind that the node ID length in Z-wave is 1 byte and the network ID length is 4 bytes. So, I was talking to you, I was mentioning about this GFSK modulation, which is Gaussian frequency shift keying. So, what happens is there is a Gaussian filter. Prior to FSK, you pass the signal through a Gaussian filter to smoothen the pulses, so that you have well formed pulses which will occupy limited spectrum width, and this process is known as pulse shaping. So, here in this figure, as we can see, this is a typical figure of a home. In this home we have different rooms, we have bedrooms, we have a living room, we have a kitchen, we have bedrooms and so on. And as we can see that if we have to implement Z-wave, we need a Z-wave controller and these different red colored and green colored nodes which are the Z-wave end devices, the Z-wave nodes. So, the controller basically sets up connectivity between each of these different nodes. As we can see in this particular example, the controller has one hop communication with these green colored nodes. However, the controller to these red colored nodes are multi-hop. Okay, they are not within the one hop communication range. So, if this controller has to communicate with this red colored node in this particular room, then it has to do via this green colored node. Z-Wave uses mesh topology and it also uses source routing. So, source routing means that even before the packet is sent, the entire route is basically encoded or embedded before the packet is sent forward. So, before the packet is sent, the entire route information is embedded to it. So, the entire route is known to the source and is given to the packet. So, the packet will know how it will traverse through the entire network until it reaches the intended destination. So, the devices, they communicate with one another when they are in range. When the devices are not in range, as I was showing you using those red colored Z-Wave nodes in the previous figure, the messages in such a case are routed through different nodes to bypass the obstructions that are created by household appliances or layout. And this is very important because, so there are so many physical obstructions in the home, right. There are walls between different rooms, etc., etc. So, what happens is there will be these different nodes which will be acting as sort of gateways or relay nodes to facilitate communication between these remote Z-Wave nodes that are not within the direct transmission range with the controller. And now we have removed the sketch of the rooms, and this is what is shown over here. We have these green colored nodes and this one which are within the direct communication range, the direct path, and then there are these nodes which are not within the direct communication range, and there they can communicate with the help of the healing path. So, this is known as the healing path and this is known as the direct path. Z-Wave and ZigBee, how do they compare? So, Z-Wave is user friendly, it provides simple system that users can set themselves. On the other hand, ZigBee requires so little power that devices can last up to 7 years on a single set of batteries. Z-Wave is ideal for someone with a basic understanding of technology who wants to keep their home automation secure, efficient, simple and easy to maintain. On the other hand, using ZigBee, ZigBee is ideal for technology experts who want a system that can customize with their preferences and install themselves. So, lot of sophistication can be done with the help of ZigBee. On the other hand, Z-Wave is more user friendly, more customer friendly, but a limited set of things can be done with the help of Z-Wave compared to ZigBee. Z-Wave is expensive compared to ZigBee, and 9 out of 10 leading security and communication companies in US use Z-Wave for smart home solutions. On the other hand, for ZigBee, there is this ZigBee Alliance that consists of more than 100 member organizations that use, develop and improve the open standard that is offered by ZigBee. Now, we come to the second very important protocol, which is the ISA 100.11a. So, it is a protocol that has been designed by the International Society of Automation, and this is particularly used for plants in the industries, industrial complexes, industrial plants and so on and so forth. There are more than 1 billion devices that use ISA 100.11a at present. It is designed to support native and tunneled application layers, various transport services including reliable, best effort, real time services are offered with the help of ISA 100.11a. So, ISA 100.11a is primarily attractive as a consequence in industrial sectors, particularly for implementing industrial IoT systems. The network and transport layers are based on the TCP or UDP or IPv6, and the data link layer supports mesh networking with frequency hopping. So, frequency hopping spectrum is typically used in ISA 100.11a. The different topologies that are used for implementing this particular standard is the star or the tree topology or the mesh topology as well. So, all these topologies can be used for implementing it, and the radio that is used underneath is based on 802.15.4 again. The permitted networks include radio link, ISA over Ethernet and field buses. Field bus means that it is a bunch of wires running between different devices, as we see in the data centers or server rooms and so on. We have these buses, and field buses means between these different field buses we have these high bandwidth, high capacity links that run between them. The application layer supports delivery of communication services to the users and the management processes. This particular thing can pass objects, methods or attributes natively within the ISA 100.11a protocol. A tunneling mode is available to allow legacy data through this particular network. So, what we have is a scenario like this. We have these backbone devices, the black colored rectangles here. We have these backbone devices. We have these non-routing devices, the red colored ones. The blue colored ones are the routing devices, and these green colored ones are the handheld devices. And then we have the security manager, the gateway and the system manager, which basically function from beyond the backbone. So, this is the typical architecture of this particular use of ISA 100.11a protocol in industries or smart factories. The features of this particular protocol include flexibility, support for multiple protocols, use of open standards, support for multiple applications, reliability including error detection, channel hopping, determinism using TDMA. QoS support is also implemented in the case of use of this particular protocol. QoS support is very important, QoS guarantees more specifically, because this is what basically ensures determinism. TDMA, we understand, time slots predefined, people know what is going to happen next. QoS support also is very important. QoS guarantees are important because we need to know that at least this is what is going to happen in the future by running this particular network using this standard. And security is also a very important feature of this particular protocol. So, security is fully built into this particular standard, the ISA 100.11a standard. Authentication and confidentiality services are independently available. A network security manager manages and distributes the keys. So, key management including key distribution, key revocation, etc., these are all taken care of by the network security manager. So, twin data security steps in each node include data link layer encrypting each hop, transport layer securing peer-to-peer communication. So, these are the different usage classes corresponding to different categories of applications. For safety, the classes are 0 and 1. 0 stands for applications such as emergency, taking some emergency applications, emergency action in some critical situation. 1 is for closed loop regulatory control, which may also be critical. Then we have category control category, which has classes 1, 2 and 3. 1 stands for closed loop regulatory control, 2 for closed loop supervisory control, and 3 for open loop control. And then we have the category monitoring, where the class 4 basically stands for applications such as alerting, and class 5 which is for logging and downloading. And this particular class, the logging downloading class, does not have any immediate operational consequence. So, with this we come to an end of this particular lecture, and we have not only gone through the ISA and ISA 100.11a protocol, but also the Z-Wave protocol in this lecture, and we have also gone through previously in the connectivity technologies different protocols such as ZigBee, which is based on 802.15.4. Then we have gone through IPv6, we have gone through RFID, we have gone through NFC, we have gone through Z-Wave, we have gone through HART, wireless HART, and we have gone through all different types of technologies that can be used for offering connectivity between different devices. These different connectivity protocols, they all have their own distinctive features which make them very attractive for use in diverse applications of IoT implementation. So, we come to an end not only of this lecture, but also the series of lectures on connectivity technologies. Thank you.